All right, welcome to our second lesson of the year. Section 1-3 on segments, rays, and distance. Hope life is going well for you so far. By the way, I'm doing this, it's getting dark out here, and I hope you can see everything okay. Let me know if that causes a problem. But let's just get going and see how it goes. Segments and rays are different than lines. How are they different? Well, a segment consists of all points between 2 points. That sounds silly by itself. Let's keep going. A segment has 2 endpoints. When we're talking about the segment consists of all points between 2 points, those 2 points are called endpoints. To say it differently, and this will clear up what was just said, a segment consists of 2 endpoints and all the points that are in between. If this is point A and this is point B, all of the points in between, there's an infinite number of them, but if we connected them all, we would end up with, well, a segment. Something that starts here at A and ends here at B, or starts here at B and ends here at A. It doesn't go past A, it doesn't go past B. It's a segment. That's why we say a segment consists of all the points, between 2 points. Hopefully that clears that up a little bit. A segment is part of a line. That's how it's different than a line. A segment is just part of a line. How do you name a segment? Well, you use the endpoints and you draw a little segment. So like this. That's segment AB. The little segment thing matters. By the way, we could also call that segment BA. Same thing. Segment AB is the same thing as segment BA. For some reason I like BA better, but I can't tell you why. If you put the arrows on the end, that's a line. So if you put a segment up above it, it's a segment. That hopefully makes good sense. Okay, that's a segment. Here's a ray. A ray is a part of the line consisting of one endpoint and all the points of the line on one side of the endpoint. So a segment has 2 endpoints, a ray has 1 endpoint. So let's see here. I got a line with a point E on it. Let's say E is my endpoint. Well, to make a ray, I'm going to look at all the points that are on one side of that endpoint. Here's all of them, and when I put them all together, well, it ends up making, well, kind of a line, but it goes just in one direction. So it has an endpoint at E and then goes in one direction. Or if you'd rather, it has a starting point at E and then goes in this direction. The definition uses endpoints, but it's sometimes easier to think of an endpoint as a starting point. All right, so what's an opposite ray? Well, look down here at this line that's given for us here. We got L, P, and Q on here. An opposite ray. Oh, let me back up for a second, Nate, before we get into opposite rays. How do you name a ray? Well, if I have these points, here's K and H that are on ray, that has an endpoint of E. How you name a ray, you start with the endpoint, and then you use another point that's on the ray. So this is ray EK. Or I can say it's ray EH. These 2 names are the same. Ray EK is the same as ray EH because it starts at E and goes in the same direction. Same direction, same starting point, same ray. All right, back to opposite rays. If we look at this line that's given for us here, opposite rays have the same endpoints, but point in opposite directions. Okay, so here is ray PQ. Well, if we have ray PQ, it starts at P. What would an opposite ray be? It's going to go the other way, ray PL. So opposite rays, if you put them together, you see how PQ goes this way, PL goes this way. If you put them together, we got this line. Opposite rays form a line. The key to opposite rays is they have to have the same endpoint. So we've already named our opposite rays, PL and PQ. And then different names for rays. If you started at L and named LP and LQ, those are the same rays. Kind of like what we did up here with EK and EH. LP and LQ are different names for the same ray. Look at question C here. Are PQ and QP opposite rays? What do you think? Do they have the same endpoints? PQ starts at P QP starts at Q. When I say starts, I'm talking about the endpoints. So no, they have different endpoints. All right, look at these couple of questions here, answer them, pause the video, and we'll talk answers. Did you pause? Seriously, I want you to pause the video. All right, here are answers. There's many correct answers to numbers 1, 2, and 3. But if you have questions about any of these, please ask before class, during class, when you'll get the chance. But please, please ask if you have a question. By the way, these are the types of questions you'll be seeing on a quiz when we have a quiz or a test. Let's keep going. The length or distance of a segment can be found by subtracting the coordinates of its endpoints. So now we're talking about a segment here, but now we're giving it a measurement, a length, a distance. Here's an example. What is the length of segment AC, this question A right here? Well, to do that, we're going to subtract. Point A here is at -8. Point C is at coordinate -2, so -8 minus -2. I'm subtracting a negative. To do that, I'm going to add the opposite. -8 plus +2 is -6. The absolute value of -6 is 6. That is the length of AC, 6. Another way we could have done it would be to count. If point A here is at -8, I'm going to count 1, 2, 3, 4, 5, 6. The length of segment AC is 6. What is BE? Now, these phrases here, the length of AC is the same thing as saying what is BE. Do you see how the length of segment AC, and then it says what is just BE without the little segment above it? This means what is the length of BE. So what is the length of BE? We're going to subtract. 2 minus -5 is 7. Question C here, what is the length of CA? This question A and this question C are exactly the same because segment AC and segment CA are the same. So their lengths are going to be the same. A quick definition. When we turn the page, there's going to be a word you've probably never seen before. Oh, sorry, before we talk about number 5 definition, this is key. There's 4 things that we've talked about here. And if we talk about AB with a line up above it, we're talking about a line. The arrows make it a line. If we put a segment above it, it's a segment. If we put just one arrow up there, it's a ray. And if we put nothing up there, what is it? Well, this is what we were just talking about. It's the length of a segment. It's these 4 things right here are keys, things for you to understand. They're kind of definitions of how we're going to define these. That was redundant. But yes, these 4 naming techniques are really, really important for you to know. All right, a quick definition. A postulate or an axiom. This is a statement that's accepted without proof. For example, turn the page over. The segment addition postulate. This is going to be important, folks. This doesn't need to be difficult. Check this out. If B is between A and C, so I got points A and C and I stick a point B in between, then by saying the word between, we're saying that B is on the same line as A and C. But if I take these points and I say the length of AB and add the length of BC, what do you get if you add AB and BC together? Those 2 segments, what does it look like you get if you put those 2 segments together? You get AC. Segment AB plus segment BC gives you segment AC. So those lengths will go together. That's called the segment addition postulate. It doesn't work, and actually I need to call these segments. This is the segment addition postulate. It doesn't work here if they're not on the same line. Okay, or if we have this here, I can't say that segment AB plus segment CD does not give us segment AD. Why not? Well, because they don't go together. Look at AB and CD. There's space in between. But we can say that AC plus CD gives us AD. You see how those are different statements. And while I'm at it, let me show you that this is the same way of saying the same thing. AC, segment AC, is the same thing as saying segment CA. But in order for this to work, there has to be a letter here that's the same. AC, CD gives us AD. CA plus DC, segment CA plus segment DC gives us segment DA. Those two equations right there are identical to each other. Just have those names flipped around. So here is how the segment addition postulate is going to work for you. Look at question number 6. If the length of dt is 60, find the value of x. Then find the length of ds, the length of st, and the length of dt. Well, here we go. dt is this entire segment. ds and st, well, s is in between, so we can use the segment addition postulate. ds plus st equals dt. It tells us that ds is 2x minus 8, that st is 3x minus 12, and it gave us that the length of dt was 60. There's an algebraic equation for us right there. Solve. 5x minus 20 equals 60, 5x equals 80, x equals 16. So there's x. Now, how would you answer the question, what is the length of ds? Well, it told us that ds was equal to 2x minus 8. Plug in 16 for x, we get 24. The length of st is 3x minus 12. Plug 16 in for x. What do we get? 36. Now, this better work out here. If ds is 24 and st is 36, they better add up to 60 because we knew that dt was 60. And they do. But that's an example of what you're going to be doing with the segment addition postulate. There'll be a chance for you to practice down here below. Another important definition. I think you've heard this term by now, but two objects are congruent when they have the same size and shape. The symbol for congruent is an equal sign with a little squiggly thing above it. So question A, or this point A here, segment AC is congruent to segment BC means that they're congruent. If it doesn't have the little, if we're not talking about segments, if we say BC equals CB, we're talking about the lengths, the measurement. These are the distinctions between what was above. We'll talk more about that if that doesn't make sense, but basically there's a difference between equal and congruent. When it says equal, we're talking about lengths, measurements, numbers. Whereas congruent means we're talking about things that are the same. Okay, midpoint. Here's another important, really postulate thing that we'll get to in just this type of this. The midpoint of a segment is the point that divides the segment into two congruent segments. When you see this word midpoint, what does it do? If C is a midpoint of segment AB, what that means that AC, the length of AC, segment AC, is equal to the length of CB. Anytime you see the word midpoint, you're going to end up with two congruent segments. So if AC equals CB, then we can set this 2x plus 1 equals 3x minus 4 and solve. When I solve, I'll get x equals 5. But that's not the answer to the question. The answer to this question said if C is the midpoint of segment AB, then find the length of AC, the length of CB, and the length of AB. But now we can do this. We know that x is 5, so 2 times 5 plus 1 is 11. That's what the length of AC is. What's the length of CB? Well, before I do this, didn't we just say that AC and CB were congruent? Well, let's see what happens. 3 times 5 minus 4 is 11. Well, yeah. If we put those two things together, we get 22. The key to answering a question like that is that it's all for x. Another last important definition here. A bisector of a segment is if you have a midpoint you have two congruent segments. Write that down, highlight it, memorize it, put it on a note card, flashcard, put it on your forehead, whatever. You've got to know this. When you see the word midpoint, you should know you have two congruent segments. Okay? Now, a bisector is related to a midpoint. A bisector is a line, segment, ray, or plane. Really, it's anything that intersects a segment at its midpoint. In other words, a bisector is anything that contains the midpoint of a segment. So if you see the word bisector, it means you have a midpoint. And what does a midpoint mean? A midpoint then means that you have two congruent segments. But the bisector is a thing that contains a midpoint. That's what you got to know. Bisector cuts it in half. It contains a midpoint. Last set of questions here. Answer these and see how you do. Pause the video. You're almost done. These are the answers. I hope you did well. We'll talk about answers. Oh, got a couple more answers here as well. Okay, get some good rest. If you have questions, we'll get them answered.